All right, so we're going to do the entire Unit 3, Part 2. And again, this is going to continue a little bit with what we talked about yesterday with Chapter 13. So this is really just essentially, do you remember this stuff from Chapter 13 about experiments? Key takeaway again from yesterday, I was trying to get this across to you guys, was if you're going to say something is an experiment, I need to see random assignment of treatments. Okay, if you're not seeing random assignment of treatments, you're not seeing random assignment of treatments, there you go. It's not an experiment. You got yours in? Take it out. Okay. All right, let's do number 1. So we have Western Electric Company is studying the effect of lighting on worker productivity. They noticed productivity increased with each increase in lighting, but then also increased with a decrease in lighting. If it is assumed that the workers knew a study was in progress, what is this an example of? It is the placebo effect. Well done, right? The idea with the placebo effect is they think they're getting medicine. Obviously, in this case, they're not getting medicine, right? They think that they should work better because they're being studied, right? It's the same way with when I get observed, right? Today, this afternoon, I'm going to get observed in P4, right? And so, of course, naturally, I'm going to be more on top of my stuff, right? Making sure that AirPods and earbuds are out, right? Making sure cell phones don't come out, that kind of stuff, where other days I might not be as on top of it. It's the same thing with your uniforms, right? Other days you just don't want to wear your uniform, right? And you don't, right? Alonzo, just don't wear it. That's cool, man. But if you're in my P4 class, I'm going to ask you to take it off. All right. Number 2. We have an estrogen blocking drug, tamoxifen. It was first introduced to treat breast cancer. There was a concern it would also cause, misspelled there, not be, cause osteoporosis as a side effect. To test this concern, cancer subjects were randomly selected and given tamoxifen, and their bone density was measured before and after treatment. Which of the following is a true statement? What do you guys think? Do you think in C? Why do you say C, Alonzo?
I don't know, because you said.
No, most students are going to pick C, but it's not C. Here's why. If this were to be C, it would need to be where you actually, bless you, were having people volunteer to be a part of the study. Then you would randomly assign some of your volunteers to take the tamoxifen and some to not, right? Take the placebo. But they're just like going down the hallway and they're like, okay, all these people in this hallway are being treated for breast cancer. All right, this one's going to get tamoxifen. This one's going to get it. This one's not going to get it. That's not really the same thing as randomly assigned treatment. So it's kind of like, it's close, right? It is close, but it's not going to be an experiment, right? What else do you guys think? You said A? Why do you say A, Ezekiel? Yeah, I mean, I'm kind of in between A and B because when I look at B, we are randomly selecting cancer patients, all right? And we're essentially just assigning them to get the tamoxifen. What I really wanted you to take away, Ezekiel, whether we say it's A or B at the end of this question, is I want you to know that we could make this so much better by actually randomly assigning treatments to our patients, okay? Now, is that ethical? No, probably not unless they know that they're a part of it, right? The clinical drug trials that exist in our country, right? People know when they sign up that they may get medicine, but they also could get what? They could get a placebo, right? A sugar pill. So they would probably need to make sure they know that's going to happen. So I'm going to say B, but Ezekiel, if you want to say A, I'm fine with that. The key thing is it's not C. Not C. No, we're just talking about topics. I'm not worried about like right or wrong yet. Okay, let's do number 3. Do you guys remember the word blocking? Remember the word blocking? Do you know what it means? No? So let's back up a chapter to chapter 12. Do you guys remember the sampling strategy that's called a stratified sample? Do you remember what a stratified sample is? Do you remember like the analogy I've used or the image I've used to think of stratified? Yeah. Do you remember what I use? Like if you go to a restaurant and it's a buffet style, right? So you get like a little bit from the meat, a little bit from the potatoes, a little bit from the green beans, whatever. That's stratified. Okay. So when you go to blocking, I always think of blocking is what stratified is to sampling. So blocking is what we use for experiments to separate first by some variable, and then we essentially run two separate experiments within those blocks. And the whole point of blocking, if you get this question on the AP exam, the whole point of blocking is to reduce the variation, right? Because if you find out, like we're going to do an example, I think later on in this packet, I think it says that there's like a difference between how men and women are reacting to something. So then we first want to block based on gender and then run two separate experiments within all the men and then within all the women, okay? If there's going to be some type of difference between them. So that's why we block. If you notice there's going to be something up, then we should account for that with a block. Okay, number 4. Oh, it's to reduce variation. Blocking is always used to reduce variation, 100%. Do you need to have blocking to have an experiment? No, you don't, right? You don't need to have blocking, right? You only should introduce it if you think that it's important. But otherwise, you don't need to have it. All right, consider these 3 things happening at a nursing home. One nursing home has pets brought in for an hour every day to see if patient morale is improved. Man, really good typing, guys. One nursing home allows hourly visits every day by kindergarten children to see if patient morale is improved. And then one nursing home administers antidepressants to all patients to see if patient morale is improved. What do you guys think? Are they using randomization? Are they like randomly saying, okay, this nursing home resident gets to see the pet, but this one doesn't? No. All right. Are any of them using randomization? No. Any of them have a control group? Do you remember what a control group is? Yeah, so really the control group, a lot of students think it's like you get nothing. It doesn't have to be nothing. It could be like a baseline, right? Sometimes a lot of these clinical drug trials they actually are given for the control group, they give them the current best drug on the market so they can compare this new drug to what's currently available, all right? Are they doing a control group in this? No. Are they doing any blinding? Remember what blinding means? No. Say it again. Exactly, right? Single blind would mean some group doesn't know what's going on, right? How do we get to double blind? Both groups don't know, right? So obviously you don't want the people to know if they're getting the placebo, if they're getting the medicine, but do we want the physicians treating them to know? No, we don't, right? In theory, we don't, because we don't want them to treat them differently if they know, like, oh, this person's getting the medicine, this person's not. Obviously, somebody needs to know, the person who's running the trial, right? But the physicians don't need to know. Okay, they can just treat them. Say it again. Well, then you would probably, if this physician was, worth their, knew what they were doing, they would excuse themselves from being a physician that's treating the patients. All right, so what are we going to go with then? We're going to go with E, right? I told you guys yesterday that how do we establish a cause and effect relationship? What do we have to establish a cause? Very good, Ezekiel. You must have an experiment. If you don't have an experiment, you cannot establish cause and effect relationships. Number 5. All right, so a consumer product agency tests miles per gallon for a sample of automobiles using each of 4 different octanes of gasoline. Which of the following is true? Now, this is asking a lot about explanatory and response variables. You guys remember the way I described those 2 variables? Do you remember explanatory? Which one is explanatory? Right, explanatory. It's the x-axis or the x coordinate, right? The x variable, explanatory. And what did I say is the response variable? The y. Okay? So I think the first thing we should decide is which one is which. Are we saying that the miles per gallon explains the gasoline used? Or are we saying the type of gasoline used explains the miles per gallon? I actually tend to agree with Ricardo. I think this is the type of gasoline explains the miles per gallon. All right, so that means type of gasoline, or these 4 different octanes, are the explanatory variables, or the variable. All right, so they're trying to confuse you with A, because we only have one explanatory variable. What is the variable? Just the type of gasoline, right? But we have 4 different levels of it. All right, so hopefully you can kind of see the idea here, right? We have one, I'm sorry, not that one. There are 4 levels, I saw the word 4, of a single explanatory variable. You're good. All right, number 6. All right, we're talking about is hot oatmeal with fruit or a Western omelet with home fries a more satisfying breakfast? I think we all would agree on this one. They have 50 volunteers, randomly split into 2 groups. One group is given the oatmeal or fruit. The other one is fed the Western omelet with home fries. Each volunteer rates his or her breakfast on a 1 to 10 scale for satisfaction. If the Western omelet with home fries receives a substantially higher average score, what is a reasonable conclusion? What do you guys think? Are you okay if I cross out D? We don't have to have blinding, right? Blinding can be helpful and important, but in this scenario, will the people know what they're eating? Yeah, they probably are going to know what they're eating. Even if we blindfold them, I think you can tell the difference between oatmeal and fruit versus an omelet with home fries, right? Even if you can't see it, probably even smell it. Okay? It's not which one? No, which one did you say? E? It is not E. You can make a conclusion. I agree with A. Here, I will say a caveat, Ezekiel, for A. If I'm going to say that Western omelets and home fries are more satisfying for breakfast than the other meal, just be aware that I have no idea any information about these 50 volunteers. So let's say all the 50 volunteers are over the age of 65. Okay? And then a person who's 30 shows up to eat. Can I really say that the 30-year-old is going to have the same opinion as people over 65? I really can't. So just be careful when you're doing this. Volunteers are not a bad thing, but just be careful that if you're going to generalize these results, make sure you're only generalizing to the same type of population. Okay? So it is A. All right, number 7. Which of the following is a true statement? You want to guess, Alonzo? Did you read them all? Yeah, which one are you going with? E, I agree. In a well-designed, well-conducted experiment, strong association implies cause and effect. Guys, that's the only way, right? So if you're going to say cause and effect, it needs to be from an experiment. That's the reason I included that question. Number 8. Some research believe that too much iron in the blood can raise the level of cholesterol. The iron level in the blood can be lowered by making periodic blood donations. A study is performed by randomly selecting half of a group of volunteers to give periodic blood donations while the rest do not. Is this an experiment or an observational study? Well, I don't think we can have blinding, right? Why can we not have blinding? Are they going to know if they're giving blood? Yeah, they're going to know. I don't think we're going to like knock them out to then have them give blood or not. That seems unethical. Are they blocking? So the way I always think of blocking is, are they separating them first and then deciding to run the experiment? Let's see. Oh, it just says they're randomly selecting half of the group to give donations and the half do not. So that's not blocking. They're not like saying, okay, first we're going to take everyone that is over the age of 30, put them in this group, and over the age of, under the age of 30 in this group, and then we'll run it. They're not doing that. So it's not blocking. So I guess the question is, do you think it is an observational study or an experiment? Are they randomly assigning the treatments? Are they saying like randomly these people get to donate blood, these people do not? They are. I mean, it may not be the best experiment I've ever read, but it definitely is an experiment with one factor, giving blood or not. All right, are we on to the free response now?
Yes.
Yes. All right, we only have 2 of these, and then we'll be done. All right, have you guys heard of this before? This idea that sugar causes hyperactivity in kids? Yeah? Have you ever read to see if that's true or not? Okay, because they've actually done studies to prove it's not true. Yeah. So whenever I hear like parents like, oh, lots of sugar, and I'm like, I mean, that's just not true. But that's okay. It's fine. Yeah, so you guys have all heard, or many of you have heard this idea that there's no such thing as like a sugar rush or sugar high. So yeah, my little brother does it all the time with his children. He's like, oh, Dahlia had a lot of cake, so she's gonna come crashing down. I was like, okay, Will, I mean, you're a smart guy. Like, it's not true. Okay, so here we go. Most parents witnessing the aftermath of cake and ice cream at birthday parties attest to the relationship between sugar and hyperactivity. Are these observational studies or experiments? What do you guys think? I mean, it may have been a while since you've been to a children's birthday party. Maybe you have, if you have younger siblings, right? Have you ever been to a party where the person's, okay, you get this, you get cake, you don't? That sounds like a recipe for disaster, right, with young children? Because, like, I know in my family, if I give 3 of the kids ice cream, what's the 4th kid going to do? Yeah, exactly. Give me the ice cream, right? So I'm going to put observational studies. Because they are not randomly assigning treatments. Okay, let's talk a little bit about what a confounding variable is. So confounding variable means that it's something that you have noticed is affecting your results. Okay, so if you realize that you have a confounding variable in your experiment, it's very difficult to then actually use those results to make any conclusions. All right, so in this case, it says, name a confounding variable to the above and explain how it is confounded with sugar. What do you guys think?
I guess their age.
Interesting. Age, yeah. Age could be a confounding. That's not the one I was thinking of, based on like what it wrote up there. What? Ooh, interesting. The quantity. These are good thoughts. I was thinking of, and again, it might just because I've been to these parties more recently than you have. But when I observe some of these parties with my children, I'll say this: the decibel level is very high. Right? Everyone's kind of screaming. It's very loud in the house because most of these kids at these parties are very excited. So if they think that hyperactivity is related to sugar, maybe they're just hyperactive because they're excited about what's going on, right? Like my son, my oldest son, we had his 7th birthday at what is it called? The place where they have all that like the indoor like American Ninja Warrior stuff and like the ball pit, and it's not it's like Jumping World, but it's not. It's a different name. It is like that though. It's if you've been to Jumping World, it's like that. I can't. Urban Air. Have you been to Urban Air? An Urban Air? So it's kind of like that. And so like all of his friends were like extremely excited because they get to just like bounce off the walls literally for like 2 hours. I mean, because they have them on like the walls too. So I'm gonna say, and you could put quantity, Ezekiel. You can put age, Ricardo. I'm gonna put the excitement of the children at the party could be a confounding variable. Essentially what I'm trying to say, guys, is if you think that a kid is hyperactive because of the sugar, maybe it's not because of the sugar. Maybe it's because of they're just super excited to go hit somebody, at Urban Air with whatever stuff they got there. Okay, let's talk about how we could design a study to help us prove whether hyperactivity is caused by sugar or not. All right, it does mention double blinding. How are we going to do this with double blinding? So they both don't know. Can you think of what groups we're talking about here? Well, I guess we can start with the kids, right? So the kids have to be blind to the fact that they're getting sugar or not getting sugar. How can we make that true? How do we make sure kids don't know that they're either getting the sugar or they're not getting the sugar? Say it again? Blindfold them? Tell them it's not sugar? There we go. Sugar-free. Do they make sugar-free sweets? Yes, they do. So we could, without telling them, we won't tell them it's sugar-free. We would give them a sweet, and they may not know if there's sugar in it or not. Right, so that's one way you could do it. How do we make sure the parents don't know? They're not invited to the party. Okay. Yeah, we would have to observe them. We could do that. I was just going to say, just make sure the parents are given the candy ahead of time, and they don't know if that candy is sugar-free or not. So, but making them not invited is, they'd probably rather go for that. Okay. So here's what I'm going to say. I'm going to say that be sure to give, I'm going to say pre-wrapped, sugar-free, and I'm going to say sugar-full candies to the parents to give out at the party. Make sure parents don't know if their kid is receiving sugar or sugar-free. Now, obviously, you could keep writing about how you would ask the parents to record their results. Maybe they would rate them on a scale from 1 to 10 for their activity level, something like that. Because at the end of the day, you do need someone, if it's not the parents, Mia, you do need someone to actually assess the activity level of the kids. What are we doing? Okay. I'm going to talk to them. You want to turn in? Sure. Great. I'll take that. And then you can come on in. Okay. Let's do our last one. Then we'll be done. All right. Our last one says a new weight loss supplement is to be tested at 3 different levels. So taking it once a day, twice a day, or 3 times a day. Design an experiment, including a control group and blocking for gender, what? For 80 overweight volunteers, half of whom are men. Explain how you would use randomization. This is a lot, guys, so ready to write many sentences here. Okay, let's first talk for a second. We've got 80 volunteers, and it says half are men and half are women. So 40 men and 40 women. Okay, now my first thought is we're going to block by gender. So I want to be very clear in how I say this. When you do blocking with experiments, right, we are essentially going to run 2 different experiments. One experiment with the 40 men, one experiment with the 40 women. So the moment you read blocking is happening, it's got to be multiple experiments. Okay? So how many different treatments are we going to assign? We've got it taking it once a day, twice a day, and 3 times a day. And let's slot in one more. Can we slot in one more as our control group? What would be a control group we could use here? 0 times a day. They're not taking it. Okay? So if you wanted to, what you could tell them, it'd be a little tougher because, like, in terms of blinding, will those people know if they're taking it or not? I mean, they'll know because they don't have a drug, right? They're like, you're not taking it. So it'd be hard to do blinding because people are going to know if they're taking it once, twice, 3 times, or not at all. So that's kind of out the window. But can we blind for the physicians that are treating them? Yeah, we could make sure that they don't know. Just say that they're in the study, right? But if they ask the question, how many times a day are you taking it? Okay, then no longer blind. So blinding will be tough here. Okay, we'll do our best. Now, how are we going to randomly assign these treatments? How do you want to randomly assign them? That's what I do, Benjamin. Yeah, I love it, right? Not actually put them in a hat. That's probably not nice. But we're going to put their names in a hat, right? So we're going to randomly put 40 of these men names in a hat. I'm going to have 2 hats. One hat for the men, one hat for the women. All right, start with the first hat. Start with the men, right? What happens with the first 10 names that I pull out? What are they going to get? Which one? I mean, you got to tell me. Oh, that's true. Me is going to go with control group. Great. First 10, control group. The next 10. Once a day. The next 10. Then the last 10. Okay, what do I do with the women? The same thing with the 40 women names, right? Do the same thing. All right, you guys ready? So we're going to write all that. That's a lot to write. Here we go. Summarize it. Okay. All right, so first, separate the 80 volunteers into 40 men and 40 women. Put all 40 names of the men in a hat. Shake the hat. Why do I shake the hat? That's my randomness. Pull out, you're good. Pull out 10 names and assign them. What do I want to say here? No drug. I don't want to say assign them the control group. I'm going to say what I'm going to do, and then that is the control group. Assign them no drug, and I'll put in parentheses the control group. Okay, man? Okay. Pull out 10 more and assign them once a day. So once a day. The next 10 are assigned twice a day. The last 10 are assigned 3 times a day. repeat this process with the 40 women. And does it say an amount of time that we need? Does it say? Like how long? Let's see. It doesn't, right? So how long do you guys want to wait for them to come back to see if this affects their cholesterol? 5 days? Probably not 5 days. A week? I'm thinking we got to do at least a couple months, right? I would say 3 months or 6 months would be probably my minimum. A year would be good. A year. Can we do 3 months, please? Okay. Sure. After 4 months, measure the results. All right, that was a lot.